Today we will start new topic, that is interconversion of states of matter. Interconversion means the conversion of solid into liquid, liquid into gas, gas into liquid, liquid into solid, or solid directly to gas or gas directly to solid. Here the interconversion of states of matter can be achieved by following two ways: by changing the temperature or by changing the pressure. Temperature and pressure. Getting this one? Temperature. With the help of temperature, if we heat solid, we see that solid starts melting and it converts into liquid state. If further we are going to heat it, this liquid, this will convert into gas. After that, if we cool the gas, we will see that it condenses. Means that cooling means that we are taking out the heat present in this gaseous substance. That is called condensation. And when we cool this liquid, means we are taking out the heat inside it. It is called freezing, or simply we can say solidification. Getting this one? Directly when we heat, this is called sublimation. That is, solid converts into gas without converting into liquid state. This is called sublimation. Similarly, or we can say vice versa, gas when directly converted into solid state, this is again sublimation, but we term it as deposition also. It is again a sublimation. Now, some substances may exist in all the three states of matter. For example, water can exist in all the three states. Here, if we take the water in the three cases, that is ice, water, and water vapor. If we take here ice, here I have taken example. If suppose the temperature of that ice cube is minus 10 degrees Celsius. Minus 10 degrees Celsius, we are giving heat. We are giving heat. What will happen when we are giving heat? This temperature will rise, increase. That is minus 10 to minus 9, minus 9 to minus 8, like this up to 0 degrees Celsius. Means that this minus 10 degrees Celsius ice will first convert into 0 degrees Celsius ice. Getting? Now further if we heating, what happens? This 0 degrees Celsius ice is converted into 0 degrees Celsius water. No change in temperature at this place because the state is being changed, solid to liquid. Due to this change in state, what happens? Temperature rise is not seen here. This we will discuss in the case of latent heat. Where the heat goes, we are giving heat here, but the heat is not shown in thermometer. This heat is called latent heat, the hidden heat. Latent stands for hidden heat. So this is hidden heat here. Now further, if we are going to heat this 0 degrees Celsius of ice water, what happens? This temperature rises. We are able to see this in thermometer. This goes up to 100 degrees Celsius. 100 degrees Celsius is the boiling point of water. So 100 degrees Celsius water we get first. Means that water starts boiling at this temperature. Further we are heating this water, again the same thing. What happened here? Same thing. Water converts into water vapor, means liquid converts into gaseous state here. 100 degrees Celsius water is now converted into 100 degrees Celsius water vapor. Heat is again given here, but no rise in temperature. You're not able to see the rise in temperature here. Clear? So here what happens? Again the same heat what you have given is latent heat of vaporization, the hidden heat of vaporization. Again we are going to heat 110 degree, 115 degree, whatever it is, 140, 200, 300, water vapor it is. Now the reverse case, what we have discussed here, the condensation and the freezing. Water vapor, 110 degrees Celsius water vapor, we are taking out the heat. How we take out the heat? By refrigerating it, taking the heat outside from the substance. What happens? Here I have written minus. Minus stands for heat is taken out. It is taken out. It converts into water vapor. Condensation starts taking place. This converts into water vapor to water. Then water to 0 degree Celsius water. Same thing, 0 degree Celsius ice. No. Yeah. Then after minus 10 degree Celsius ice. Okay. The effect of change of temperature can be explained with the help of an experiment also. The experiment, first of all, we have to take about 150 grams of ice in a beaker and place a thermometer so that its bulb is in contact with ice. Thermometer bulb is in contact with ice. Now start hitting the beaker. You see here. You will see that I have drawn a figure here. This is a beaker in which ice cubes are placed here. A thermometer hanging in stand. The bulb of this thermometer is in ice cube. Now we start hitting this beaker filled with ice cube. This is called Bunsen burner. Used in laboratories. Now, when heat is supplied to ice, the kinetic energy of the solid particle increases. Solid particles' kinetic energy increases. As a result, they start vibrating with high speed. Their vibration, we have already discussed in the previous section, characteristics of particles of matter, that the matter is moving continuously. Particles of matter are moving continuously. The result, they start vibrating with high speed. On further increasing temperature, the heat energy overcomes the forces of attraction between solid particles. See this one, this line very important. Further increasing temperature, the heat energy overcomes, that is very important here, overcomes the forces of attraction between solid particles. The heat energy is utilized in overcoming the forces of attraction between solid particles. At this temperature, particles leave their fixed position, start flowing, and the solid melts to form a liquid. We can say that when we simply say that these two are particles and these two particles are, when the force of attraction decreases, therefore what happens, little bit space increases. This is, and due to this what happens, they start slipping over each other. The particles of matter start slipping over each other. Due to this slipping over, the solid starts flowing, and the solid melts to form a liquid. This is the experiment to explain the effect of change of temperature on the three states of matter. Getting any confusion here? Yes, see this one now. Now some definitions. Melting, the process or the phenomena in which solid substances are converted into liquid state is called melting. Which solid substances are converted into liquid state is called melting or fusion. Melting point, the particular temperature at which the complete solid is converted into liquid state is called melting point. Which the complete solid is converted into liquid state is called melting point. When heat is further supplied to the liquid, kinetic energy of liquid particles increases further. As a result, intermolecular space increases. Hence, the magnitude of force of attraction holding the liquid particles becomes so less that the liquid particles break apart from the liquid state and changes to gaseous state. This we have already discussed. See here. Now, boiling. Same thing as we have discussed earlier. The process or the phenomena in which the liquid substances are converted into gaseous state is called boiling. Boiling point, the particular temperature at which the complete liquid is converted into gaseous state is called boiling point of that substance. Same thing, on decreasing temperature, by cooling, the particles of matter lose energy, due to which they move slowly. When we are taking out the heat energy or the energy from the substances, they start the kinetic energy decreases. They lose energy, due to which they move slowly. If we continue to lower the temperature, then the particles of matter stops moving and vibrates around their fixed position, or simply we can say mean position. Mean position means here, suppose this is the particles of matter are moving like this, then again coming back, then again going to another direction, then coming back. This is called the mean position. This is mean position, moving around the mean position. Now condensation, the process or the phenomena in which gaseous substances are converted into liquid state is called condensation. Condensation point, the particular temperature at which condensation takes place is called condensation point. Freezing, same thing. The process or the phenomena in which the liquid substances are converted into solid state are called freezing. Freezing point, the particular temperature at which the liquid substances, very important thing is particular temperature. Here also particular temperature, that is fixed temperature. Same thing here also, particular temperature. You can see this particular temperature at which the phenomena is taking place is called the point, either the boiling point or the condensation point or the freezing point. Now we come to the next important topic, that is latent heat. Latent heat. Latent heat. What is the meaning of latent heat? As we have already earlier discussed, that the minimum amount of heat required to convert 1 kg of substance, 1 kg of substance from one state to another without rise in temperature, that is important, without rise in temperature, is called latent heat of that substance. Getting what we said? The minimum amount of heat required to convert 1 kg of substance from one state to another without rise in temperature is called latent heat of that substance. It is of two types, as we have earlier discussed: latent heat of fusion, latent heat of vaporization. Latent heat of fusion, the minimum amount of heat required to convert 1 kg of solid substance completely into liquid state. Same definition, liquid state, but here it is solid substance into liquid state without rise in temperature is called latent heat of fusion of that substance. For example, latent heat of fusion of 1 kg of ice is 3.34 into 10 power 5 joule per kg. This means that 1 kg of ice, 1 kg of ice requires this much, 3.34 into 10 power 5 joules of energy to convert itself completely into liquid state, that is water. It's ice. Here we have taken ice, so here it is water. Now the latent heat of vaporization, same thing. The minimum amount, again the minimum amount of heat required. The minimum amount of heat required to convert 1 kg, again here, of liquid substance completely into gaseous state. Of liquid substance into gaseous state without rise in temperature is called latent heat of vaporization of that substance. Same definition, but here from liquid to gaseous state, here solid to liquid state. Now example, the latent heat of vaporization of 1 kg of water is 22.5 into 10 power 5 joule per kg. Here we have discussed that for ice it is 3.34 into 10 power 5 joules, but here it is 22.5 into 10 power 5 joule per kg. This means that 1 kg of water requires minimum 22.5 into 10 power 5 joules of energy to convert itself completely into gaseous state. It means that 22.5 into 10 power 5 joule of energy is extra in the gaseous state at the same temperature. Same way here also we can say that 3.34 into 10 power 5 joules of energy is extra in the liquid state in comparison to the solid state at particular temperature, at same temperature. So here the next topic we come on, that is sublimation. Sublimation, as we have already discussed, that sublimation is directly conversion from solid to gas without into converting into liquid state is called sublimation, and vice versa. Sublimation is the process of conversion of a solid directly into a gas or vice versa without changing into a liquid state. That is very important, without changing into a liquid state. See here, solid, gas directly heating, that is called sublimation. Again we are taking out heat, that is cooling or deposition. For example, we will take very important example is this one, sublimation of solid ammonium chloride. Solid ammonium chloride, very important one. Sublimation of solid ammonium chloride. See, first we have to take a inverted funnel keep, you know very well, inverted funnel. We have taken a inverted funnel. Now we have taken a tripod stand, the wire cage or mesh we can say, made up of iron. Here we have taken a china dish. This is a china dish on which we have placed some ammonium chloride, impure ammonium chloride we have taken here. Solid, this is solid also, solid ammonium chloride, impure ammonium chloride, it is solid. Now we have closed the mouth of this funnel with the help of cotton plug. Cotton plug, we have closed the mouth of this one. Now with the help of Bunsen burner, we start heating this solid ammonium chloride. What happens? We see that after some time, this solid ammonium chloride converts into vapors. That is vapors of ammonium chloride. You can see here, vapors. We don't see that it is converting into liquid state, directly into vapor. Vapors of ammonium chloride, it is seen. When these vapors move upside, the temperature decreases, and what happens, this condenses, this vapor condenses and sticks onto the walls of the inverted funnel. That is solid ammonium chloride. This is pure one also. This is pure, means that we can purify the impure ammonium chloride with the help of this one also. So here we have seen sublimation, solid into vapors, that is gaseous state of ammonium chloride. And this vapors, when here the temperature decreases from this position to this position, there is difference in temperature. Here the temperature is high, here the temperature is low. What happens here, this temperature decreases and this ammonium chloride vapors sticks on the wall. They condenses directly into solid state, vapors directly into solid state. That is called deposition or simply sublimation. This is with the help of this experiment we know about the sublimation.